Hi everyone, my name is Praful Kumar and today I'm recording this video for subject design and analysis of reconfigurable systems, and this is homework 4. So today we are working on D1 SOC. So for that, the first thing I have to do is go to file and then click on new project wizard. So since I have already created a new project wizard, so I'll show you the project window. So if you can see, these are the relevant files for the project. So this is there is I2C protocol, and there is Verilog for the sound module, and then there is a STC for constraint. Yeah, so now I'm gonna compile this and show it to you. Okay, so now we have successfully compiled the code. I'm going to show you the timing analysis. You go on to the timing analyzer. So this is the timing analyzer window. So here let's get the maximum operating frequency of the circuit. So you do that by going to, yes, here you can see F max. So this is the maximum operating frequency of the circuit. You click on this. Okay, so if you could see, we have the maximum frequency of the circuit, which is 270.2 megahertz. So now I'm going to show you how you can extract the timing analysis of the circuit. You click on report timing here. Okay, for the number of paths I'll choose 5 for now, and then I'll click on report path, report timing option. So yeah, if you could see, this is the slack of the critical paths, and this is from the node to the node, and this is the data delay, and here if you could see, this is the clock skew. Okay, so next I'm gonna show you how you can do that for 2 nanosecond. So I'm gonna change the constraint file to 2 nanosecond. So these results I showed you just now are for 20 nanoseconds. So for that you have to go to STC file. So here you change it to 2 nanoseconds. So I'm basically changing the constraints. Click on save. I'm gonna make this a top level entity, and then I'm gonna recompile the code. So now I have successfully compiled the code, so I'm gonna run the timing analyzer again. Okay, so now I'm gonna show you the critical paths. So I'm gonna click on this report timing. Okay, if you could see, this the number of paths are 5. I'll click on report timing. Okay, now if you could see, there is a timing violation here because the circuit is not going to work for 2 nanosecond clock period. So the slack is negative, and the clock skew is also negative here. So yeah, so now I'm gonna make the change back to 20 nanosecond, and then I'll show you how you can move the LUTs around the chip planner. Okay, so now we have successfully compiled the code. I'm going to show you the timing analysis of the code. gonna click on report timing here. I'm gonna click on report timing. Okay, so this is the Slack. So I'm gonna click on this one of the node. You right click on this. I'm gonna check this on check this the chip planner. It's gonna take a while. Okay, if you could see, this is the critical path here. So what I'm gonna do is I'm gonna move one of this. So I'm gonna click on assignment here. I'm gonna change the editing mode to assignment, and then I'm gonna so okay, I'm gonna move that to somewhere here. Okay, so now that is done, I'm gonna save it, and then I will again recompile the code. So now if you can see, I have successfully reduced the slack by moving one of the critical path. Okay, so let me show you. So if you could see, we have successfully moved the LUT from that was here, right? Let me show you. Okay, it was somewhere here, around here, but we have moved that to here, so that contributed to the reduction in slack. So yeah, that is it for now. Thank you.